So on page 2 of our notes here, you're going to see some helpful tips as we kind of add some pieces to these problems and start to build a little bit. So this first statement says, when simplifying identities, we often rewrite in terms of sine and cosine. One of the biggest things is to get things to common terms so that, you can look for things to cancel or you can put pieces together. And we traditionally go to sine and cosine because they're kind of the basic two trig functions. And that being said, we kind of treat sine and cosine like royalty. They have immunity, meaning we don't touch them. So unless you absolutely need to convert a sine or a cosine to something else, we typically leave them alone. Another thing, and this is one where you have to kind of watch yourself, is we don't have to use every identity. As you saw in those first 6 examples, we really only used one identity and then we used some like old math skills. So based off of the problem that you're looking at is how you're going to decide, do I use Pythagorean identity, the reciprocals, the tangent, cotangent, really what works best for this problem. And another thing not listed here is just be prepared to try and be okay with failure. I mean, it's horrible to say that, but if you go into this thinking I have to have it straight out the gate, that's the wrong mindset. You may need to watch through this video several times before you really pick up on all the little nitty-gritty details. And that's okay. Know that, every single one of us did not come out of the gate swinging at 1,000%. It's just facts of life. So let's take a look and we'll take it slowly. I'm going to do each problem kind of in a different fashion so you can see all the ways of the ways that these could be presented to you. So let's start here with example 1. And another thing, as we take a look at this first example, I'm actually going to give you, and from time to time they will do this, I'm going to give you the other side. So this is going to look more like that proof that I was talking about in the last on the last page. So our target here, or the proof statement, if we were making this a true 2-column proof, is that this should simplify to secant x. Now, if we take a look, we're looking at cosine of x plus tangent x sine x. I noticed that, again, we want to keep sines and cosines, and if they're not sine and cosine, we want to transition to that. So the only non-sine cosine is tangent. So I'm going to use my tangent identity, which says that if I rewrite this cosine x plus, I can rewrite this as sine of x over cosine x by our tangent cotangent identity, and then this would be times sine of x. Again, I'm going to put this over 1 here just so we can show that that's a fraction. I'm also going to put cosine of x over 1 since we brought in the idea of fractions. And then remember from our rational expressions review on Friday, when you're adding fractions like we are in this case because of the plus sign right here, we need to get to a point where we have a common denominator. Okay. What I want to do though first is I'm actually going to combine these two fractions because they're being multiplied before we do the addition. So cosine of x for now I'm going to leave alone, plus, and then if we multiply across the top we'll get sine squared of x over multiplying across the bottom would be cosine x. Now to get this thing to be a common denominator, clearly I can manipulate the cosine x over 1 to whatever I want because it's over 1. So in this case, I'm going to choose to multiply this fraction by cosine x in the top and the bottom. So I get that common denominator. Or if you recall, this would be the same as that bottom diagonal, BDD. So now I'll have cosine squared of x over cosine x. And then we can go straight to one big fraction because now the denominators will be the same, plus sine squared of x. Now, at this point, I'm kind of stuck. Everything's already in sines and cosines, so I can't really transition anything else. So how do I proceed? What else do we notice that would come off of that identity sheet perhaps? Because I can't, if I start to reduce things, I'm going to go backwards. And I certainly don't want to do that. Also keeping in mind that our end goal is to get a secant x out of this. So at some point I am going to have to convert to secant. But obviously I'm not ready to do that just yet. Well, hopefully again, the fact that there are squared signs here and here is indicating to us that we should maybe look at those Pythagorean identities. So I'm going to bring this over here. Cosine squared x plus sine squared x is actually written slightly backwards, but it is the original Pythagorean identity that you've learned. So we can take the top of the fraction and replace that with a 1, and then we have 1 over cosine x. Now, again, keeping in mind that I want to get down to a single trig function and I want it to look the cleanest or the easiest, prettiest, whatever you want to call it. In this case, it makes sense why they said the final answer would be secant x, because I can use my reciprocal identity and get rid of the fraction, because cosine of x, 1 over cosine of x rather, is the same as secant x. All right. Let's take a look at example 2. So example 2, same deal. I notice here that everything is either 1 or it's already cosine. So transitioning to sines and cosines, check, that's already been done for us. I notice, though, that I have a binomial, 1 minus cosine y, times another binomial, 1 plus cosine y. So maybe I just start with some old stuff, which would be FOIL or box, whatever your preference here, where I'm going to multiply these two binomials together. I prefer to do FOIL. I don't, like drawing out the box, so I'm going to walk you through those steps. But again, if you need to, this would be a 2x2 box that you could build to do the multiplication. So if we FOIL, we do the first terms and do 1 times 1, which is just 1. Then we do our outsides. 1 times cosine y would be just cosine y. When we do the inside terms, we do negative cosine y times 1, so negative cosine y. And then last terms would be negative cosine y plus cosine y, which would be negative cosine squared of y. Now, you should notice something. Again, if we kind of look at this from ignoring the trig for a minute, look at like terms. You should notice that we have a positive cosine y and a negative cosine y. So what can we do with those two terms? Well, we can cancel them. They're opposites. So this is really the same as 1 minus cosine squared of y. I feel like we've seen this before. What you should be thinking about is that this is that kind of derivation of the original, again, Pythagorean identity. So if you remember, you can just simply write that this is equal to sine squared of y. If not, then you can take sine squared y plus cosine squared y equals 1 and get the 1 and the cosine squared on the same side and get it that way. Note that, going forward on any assessment, you will have the original 3 Pythagorean identities, but we will be manipulating those 3 and solving for all of the different pieces within each of the 3 originals. So, like this one right here, you might already have memorized that because we've now seen it twice. If you haven't, I'm sure that as you continue working, you're going to start to pick up on it a little bit faster and won't have to write it down every single time. All right, example 3. We just have a simple fraction, tangent of x over sine of x. So again, I'm thinking right out the gate, let's just start by converting to sines and cosines, which means I can take tangent of x and replace it with sine of x over cosine of x. Now, careful here because we have a fraction now within the bigger fraction. So I'm actually going to draw the original fraction bar in a different color just so it stands out a bit. And now this is sine of x is the denominator of the big fraction. Again, because we're working with fractions, I'm going to make the denominator a fraction as well and make that a 1. And then again, I'm going to pull from old math skills. When we have a fraction within a fraction, or if we're dividing with fractions, we learned on Friday, we can do that same change flip. So I'm going to rewrite this. I'm going to go this way this time. I'm going to rewrite this as sine of x over cosine of x. That's our keep the numerator the same. But then that red division symbol that I put there for the original fraction bar, I'm going to change that to multiplication, and then I'm going to flip the denominator of the original fraction. So now that's why it was important that I wrote sine of x as a fraction, because this is really 1 over sine of x. Now, hopefully you notice something here. We have sine of x over cosine of x times 1 over sine x. Again, if you recall from the lesson Friday, you can make this one big fraction if you want to extend the line there. But what the bigger thing is that you should notice that there's a sign of x in the top and the bottom, so they're allowed to cancel out. So in this case, cleaning up a bit, we have 1 over cosine x, which again, we get a final answer of secant x because we can use that reciprocal identity. So if we kind of just jot ourselves some notes here, this first one was tangent cotangent identities. The second one was same change flip, or whatever you want to call it. And then the third step, we canceled or simplified the fraction. Yeah, that's right, simplified fraction. And then the last step is our reciprocal identity. And this is really the only time where we're getting rid of that cosine, because we like to keep things in sines and cosines. This is really the only time where we're going to convert out of sine and cosine, because it's easier to look at this as our final answer than it is as the 1 over cosine x. And I know some of you might argue that that's not true, but in this case, if we can get it to a non-fractional answer, that's the way that we would prefer that it would be written. All right, example 4, and if at any point you're feeling comfortable and confident enough that you want to pause the video and try it yourself first, I think that's a great strategy. One of the things that I've learned personally is that, if you put yourself to the test and then kind of figure out your mistakes after the fact, that kind of makes it go a little bit easier because you can figure out what you really need to understand and know what to do. So feel free, again, to pause at some point and try any of the remaining examples here. All right, so for example 4, I've got a fraction again, and this time right out the gate, I notice there's no sines and cosines. So that seems like a great strategy to just start by converting to sines and cosines. So cotangent, we can use that tangent cotangent identity where we convert to cosine of, this is called alpha. It's kind of like a little fish, over sine of alpha. Again, I'm going to put the original fraction bar because we're going to have fractions within a fraction. In that red color, and then cosecant of alpha is 1 over sine of alpha, and this is actually, so we use 2 identities in this first step. The top was cotangent tangent, the bottom is a reciprocal identity. Now, here again, because we've got a fraction within a fraction, I prefer to get it all on at least one level, get rid of that red fraction. So I'm going to use keep change flip again. So cosine of alpha over sine of alpha, leave it alone. I'm going to change that division or that red fraction bar to now a multiplication. And then we've got 1 over sine of alpha, we're going to flip it. So this becomes sine of alpha over 1. Here again, you can draw the fraction bar the whole way across if you want, because now we're just multiplying across the top and across the bottom. And again, the same thing happens as did in the last one. And actually, it's the signs again. They cancel out because we have 1 in the top and in the bottom. So this one, if we go one more step, we've got it. We're just left over with a cosine x, and we don't have to write the over 1 at this point. No need for that since we're no longer working with a fraction. All right, 2 more, and then it's your turn. Example 5. So straight out the gate, again, a couple different strategies here. I notice that the top is not in sines and cosines, so maybe you're thinking, let's convert. The bottom is in a cosine format, so we don't need to do anything with that just yet. But another strategy is to look at the fact that they gave us squared terms. And again, when we start to see those squared terms, I always like to look first and see if a Pythagorean identity will get the job done. And the good news here is that cosecant and cotangent are in one of the Pythagorean identities. Now, again, it's not the one that's on your formula sheet. It's a derivation of it. So I'm going to write the one that's on there and we'll manipulate it to match what we need here. So the one that's given to you is 1 plus cotangent squared of x equals cosecant squared of x. Based on what we're looking at here, we want the cosecant and cotangent on the same side. So I'm just going to subtract the cotangent squared to the other side. And we'll notice that this is now just 1, and this matches what was given to us in the problem. So that's pretty awesome. Right out the gate, I can use Pythagorean identity and say the top, that all goes to a 1. And we've seen this one now a couple times. 1 over cosine of alpha, we can use our reciprocal identity to simplify it one step further, and we just get secant x. Now, if you would have converted to sines and cosines straight out the gate, would you still have arrived at secant of alpha? Absolutely. Would it have taken a lot more steps? Probably, because you would have had to use the sine and cosine Pythagorean identity, but you would have also had to deal with some fractions, maybe combining like, not combining like terms, making a common denominator, that kind of thing. So know that there are more than one way to go through these, but sometimes you find the faster one right away, and other times you just have to go down a path and work it out until you get to the finish line. There's not necessarily just one right way to do these. All right, and then our last example, they're throwing a beta in at us this time. Right out the gate, again, notice that they gave us a couple things. First of all, everything is almost in sines and cosines except that secant. And again, I see a squared sign. So, you can start wherever you want with this. I personally think that I'm going to start with the 1 minus cosine squared. We've seen this one a couple times. I think I'm going to start by changing that out for sine squared of beta, because we can look at Pythagorean identity, the original one, and that manipulation that we've been using a couple times. So let's rewrite secant of beta over sine of beta. And then I'll put the times symbol here, and this would be sine squared of beta. And because we're working with fractions, I'm going to put that over 1. Now, again, I already mentioned that secant can be converted to 1 over cosine of beta, but that gets me a fraction within a fraction. So I'm going to hold off for one more moment and see if I can do something else. Again, I notice that there's a sign in the top and in the bottom. The only issue is that I can't just go crossing them off because of the squared sign that's on the numerator. So again, let's think of this. I'll write it off to the side. If we thought of sine as x, what this fraction is saying is we have an x squared over an x. How could we rewrite that using something from prior knowledge? Well, if you recall, exponent rules allow you to subtract exponents when you're working in a fraction. So x squared over x, you probably wouldn't have even thought twice about this. You would have all written that as just an x. We're going to use that strategy here. In this case, what I'm going to do is I'm going to cross out the squared sign here to indicate that I took away one of them and canceled it with the one that's on the bottom. So what we can do going forward is we can write this now as no fraction. It would be secant of beta times sine of beta. Now what can we do? Well, at this point, sine and secant don't have a relationship with one another, but we said it a couple times, we can convert secant to a cosine. So let's see, because now we got rid of the fractions, and this will be our only fraction in the problem. Let's convert this to 1 over cosine of beta. And again, I'm going to put a fraction bar here with an over 1. So at this point, I can just multiply across, and we get sine of beta over cosine of beta. What do we know about sine over cosine? What does that actually equal? Good news, we have an identity for that. It's the tangent-cotangent one. Sine over cosine is tangent. So tangent of beta is our fully simplified answer here, which again is much easier in this case. I don't think you could argue it. If I had to plug in an angle for beta, I would much rather plug it in down here at tangent of beta versus plugging in 3 different betas, having to deal with this squared sign and all of that jazz to be able to simplify the problem. If I knew that I could just plug it in right here, that would be awesome. So at this point, obviously, you're probably in a couple different places depending on how well you're understanding. You're probably thinking, this is absolutely crazy. Why would we ever make you do this? Or you're thinking, I kind of understand a little bit what's going on, but I'm definitely going to need some practice. Or maybe, crossing our fingers, but it's okay if that's not where you are, you're thinking this is super easy. It's the easiest thing we've done all semester. Regardless of what step you're on, what we have for you up next is a matching in Google Slides. So you're going to get to practice this a little bit more by matching them together. So again, similar to how I did the first one, I'm going to be basically giving you what the final answer should look like, but you're going to have to pair it between 5 potential different matches, but they all will end up matching together. So if you need to, again, I would strongly encourage you to go back and rewatch any of this just to pick up some minor details that maybe you missed the first time around. And again, don't stress out about it. We're going to do this a couple more times and keep practicing with it. So I wish you the best of luck, and feel free to reach out if you need anything.